Welcome everybody to this final video of the YMFC 3D video series. First, I would like to thank everyone for the comments and the likes on the videos that I made. In this video, I'll explain the last bits and pieces of the flight controller program. But first, I'll show you some of the capabilities of this multi-copter controller. Now this is the final program that you can download. I'll put a link in the description. Now please pay attention to the terms of use at the top of the program and don't forget to watch all the videos in this series so you fully understand the complete workings of the code before you use it. Now the most part of this program are already explained in other videos. So in this last video I'll only explain the last bits and pieces that connect all the previous parts together. Now this part of the program controls the starting of the multicopter. For safety, the multicopter only starts after a special stick sequence. This first line sets the start variable to 1 if the throttle stick is in the lowest position and the joystick is in the left corner. This second line waits for the joystick to get back in the center position. After that, the start variable is set to 2. And when the start variable is set to 2, the multicopter starts. Now to make sure we get a bumpless start, these lines reset the memory of the I and D controllers. Now to turn the multicopter off, the start variable needs to be set back to 0. Now this can be done by lowering the throttle stick to the lowest position with the joystick in the right corner. Now to prevent the multicopter from jawing while turning the motors off, the jaw receiver input is disabled when the throttle stick is in the lowest position. In this part, the pulses of the ESCs are calculated. The throttle input forms the base of all the ESC signals and is loaded into the throttle variable. To make sure the PID controllers have enough room to correct the multicopter at full throttle, the throttle is limited to 1800 microseconds. This way the PID controllers can add an extra 200 microseconds when needed. To calculate the pulses of the ESCs, we only need to combine the separate PID outputs and add or subtract them to the throttle signal. This picture that I have shown before represents the roll, pitch and yaw axis of the multicopter. When the multicopter rolls right wing down due to wind or turbulence, the gyro senses a positive roll. When the receiver input is 0 degrees per second, the output of the roll PID controller is positive. So when the multicopter needs to stay level, the RPM of the front right motor needs to increase when the multicopter rolls right wing down. Now this is done by adding the PID roll controller output to the pulse of the ESC1. Now the same goes for the pitch. When the nose of the multicopter goes down, the gyro senses a negative pitch angle and the output of the PID pitch controller is negative. By subtracting the PID pitch controller output, the motor RPM is increased. The second ESC is on the rear right. Its pulse is a combination of positive pitch PID correction and a positive roll PID correction. And we do this for every motor/ESC combination. Now all the motors are at the same distance and angle, so we don't have to do special calculations. But when needed, you can calculate your own multicopter layout this way. Torque is used to yaw the multicopter. To do this, the RPM of the counterclockwise motors need to be different from the clockwise motors. Now this is done by adding or subtracting the yaw PID controller output from the ESC pulses. Now motor 1 is rotating counterclockwise, motor 2 clockwise, motor 3 counterclockwise, and motor 4 clockwise. So when we want the multicopter to yaw right, the receiver input is a positive degrees per second value due to the standard of this picture. Now because the multicopter is not yet moving, the gyro is 0. The output of the PID yaw controller is negative. This means that motor 1 and motor 3 increase speed and motor 2 and motor 4 reduce speed. As a result, the multicopter will turn in the opposite direction of motor 1 and 3, and that is to the right. When all the pulses are calculated, they need to be corrected for voltage drop. Now this is done in this section. The voltage drop is measured and divided by 3500. After this, the result is multiplied by the ESC pulse and added to the current ESC pulse. With this, the multicopter hovers at the same stick position regardless of the battery voltage. And the PID corrections stay the same, so the multicopter stays locked in during the complete flight. So if your multicopter is dropping during flight, lower the 3500. And if it rises during flight, increase the 3500. And last, it is necessary to keep the motors running at low throttle position. This increases the stability during fast descents. During corrections, we don't want the pulse of the ESCs to go back to 0 microseconds, because this will turn off the motors. And with this, the last parts of the program are explained. Now you should be able to further develop the code for your own purpose. I hope that this project opens the door for many people who would like to start building their own multicopter flight controller. Thank you for watching and supporting this video series. Now don't forget to subscribe and see you next time.